Powers of tangents and secants. So consider the trigonometric integral form of the integral of tan raised to m v secant raised to n v dx. Okay? So alam natin na yung integral, ito ay ano lang natin. Yung integral ng secant u, tan u, du is equals to secant of u plus c. Diba? So, yun yung ating mga unang topic. So, if m is equals to n is equals to 1, we evaluate the integral of that. Yung sinabi ko nga, yung integral of sin u, tan u, du is equals to secant of u plus c. If m is equals to any number and n is equals to 2, we evaluate the integral of the ordinary method of substitution used in the integration process. For example, that tangent or the integral of tangent cube x secant squared x dx is just equals to the tangent of tangent raised to 4x or tangent of x raised to 4 all over 4 plus c. Bakit? Kasi nga, ito, yun yung ating u, where u is equals to tan of x, diba? So, alam natin yung u raised to n plus 1 all over n plus 1, diba? So, ito yung ginamit natin dito. Diyan, okay? So, after that, bakit nawala yung secant squared? Kasi nga, yung kanina sinabi natin, diba? Na kapag meron tayong integral of secant u, tan u, du, that is equals to secant of u plus c. Diba? Okay. So therefore, dito sa ating example na ito, if we have u as tan of x, then yung ating du for that is secant squared x dx. Okay? Kaya yung du natin ay nandito kanina, diba? But before tayo nag-plus c. So, elaborate natin. So, ang mangyayari kasi dyan, that would be equals to the integral of tan of x raised to 3. Tapos, ito, yun na yung du. Ito yung u. Okay, palitan natin. U cube. Tapos du. Ganon yung nangyari. Okay? So, that would be equals to equals u raised to 4 all over 4 plus c. Okay, then palitan natin where u is equals to tan of x. Okay, so this would be equals to tan of x raised to 4 all over 4 plus c. So, yun. So, in this module or in this process, we shall consider the following cases. Case number 1. So, katulad ng mga nauna na method of integration, we have set of cases. So, case number 1. We have, when m is any number and n is a positive even integer greater than 2, okay? So may ano na, greater than 2. So example, or yung ating formula, tan raised to m, v, secant of n, v, that would be equals to tangent raised to m, v, secant of n minus 2. Ito yung binabanggit. Okay? V. Then, yung nandun sa baba, kung kanina minus 1, then yung nandito sa dulo ay secant lang. Dito ay may squared siya. Okay, so ganun yung process. And then use again the identity, yung secant squared, v minus 1 plus tan squared v. Then to reduce the given integral to the form that is equals to the integral of the sum of powers of tangent multiplied by the secant squared v dx. Example agad tayo. So example number 1. Evaluate the integral of tan cube of x secant of x raised to 4 dx. So, ito yung 4 yung gagawin natin kasi ang case number 1, yung n yung greater than 2. So, yung m natin dyan is 3, yung n is equals to 4 minus 2, di ba? Kasi mag-minus tayo ng 2. So, this should be equals to tangent of x raised to 3. Tapos ito ay magiging siyang secant of x squared na 2. Okay? Secant of x squared dx. Tapos ito ay meron siyang trigonometric identity. So this should be equals to tangent of x cubed quantity 1 plus tangent of x squared plus quantity secant of x squared dx. Therefore, dito ay pwede tayong distributive property. This should be equals to tangent of x cubed plus tangent of x raised to 5. Okay? Then, multiplied by the secant of x squared dx. Okay? So, ngayon, alam natin na yung ating u is equals to tan of x and yung ating du is equals to secant squared x. Okay? So, this would be equals to tangent 3 plus 1 is 4 all over 4 plus tangent of x raised to 5 plus 1 is 6 all over 6 plus the arbitrary constant c. So that is now the final answer for our problem number 1. Next, case number 2. For case number 2, when m is a positive odd integer, ngayon m naman, no? And n is any number we may write, tangent of v raised to m, secant of v raised to n, is equals to a quantity tangent of v m minus 1. Sorry. Then secant of v n minus 1. Then multiply by secant of v tangent of v. Then use again the formula or trigonometric identity na tangent squared v is equals to secant squared v minus 1. Yan. So halimbawa, number 1, evaluate the integral of tangent of x cubed secant of x to the 5th power dx. So yan. So ngayon, alam natin na yung ating So alam natin na yung ating yung ating tan squared v is equals to secant ito. Yan yung i-replace natin. So that will be integral of a quantity secant of v squared minus 1. Then ilalagay ulit natin ito. Kasi in-expand natin yan, di ba? So hindi pa pala tayo nag-expand, sorry. Yan, expand natin, magma-minus lang naman tayo ng isa dyan. So integral of tangent of cube, squared na lang, no? Then secant of raised to 4 na lang yan kasi minus 1. Tapos dito ay ilalagay natin yung isang tinanggal natin. Yan. Tangent of x dx. Okay? Yung tan of x squared is equals to a quantity secant of x squared minus 1. Okay? Then ito, copy mo lang. Secant of x raised to 4 secant of x tangent of x dx. Then we can distribute the property ulit. So this would be equals to the integral of secant of x secant of x raised to 6, no? Minus secant of x raised to 4. Yan. And then, eto na lang. Secant of x tangent of x dx. So again, yung ating u for that is equals to secant of x and yung ating du is equals to secant of x. Bakit ba nagiging ganito? Sorry. Secant of x tangent of x. Okay? So ito ay pwede na natin integrate. So this should be secant 7 or 6 plus 1 is 7 all over 7 minus secant of, yun na naman, mali na naman. Secant of x, 4 plus 1 is 5 all over 5 plus the arbitrary constant c. So ito yung sagot sa ating case number 1 problem. Okay? So, yung case number 2 pala yun. Yung case number 3, ito yung last. Yan. Case number 3. When n is a positive odd or even integer and n is 0, kapag merong 0. So, ayan, basahin nyo na lang yung nandyan sa module. So, sa case number 3 example, we have the integral of tangent of x raised to 5 dx. So, in this case, we can rewrite this as tangent of x raised to, ito, ano mo lang, no? Minus 2 kasi tayo dyan, di ba? So, raised to cube. Then, copy mo lang yung natira. Tan of x, may natirang dalawa. Then, dx. So, in this case, yung ating tan ay merong value. So, this would be integral of tan of x cubed multiplied by the secant of x squared minus 1 dx. Then, distributive property. So, this should be equals to the integral of tan of x cubed secant of x squared minus tan of x cubed dx. Okay? So, in this case, yung ating u is equals to tan of x dito. Tapos yung ating du is equals to secant squared of x. Okay? So, dito naman sa kabila, ito ay pwede pa natin gawin. No? Pwede pa. Kasi wala pa tayo ditong du. So, expand natin ito. So, this should be equals to the integral of tan of x cubed secant of x squared minus tan of x and then tan of x squared dx. Ito ay merong value ulit. So, this should be equals to the integral of tan of x cubed secant of x squared minus tan of x times secant of x squared minus 1 dx. Tapos ito, pwede mong i-distributive property ulit. Therefore, this should be equals to the integral of tan of x cubed secant of x squared minus tan x secant of x squared minus tan of x dx. Okay? Therefore, we can now integrate this one. So, this is equals to ito ay tangent of 3 plus 1 is 4 all over 4. Wala na ito dahil yun yung du nung tangent of x, di ba? Minus tan of x squared kasi 1 plus 1 all over 2. Wala na yung secant squared, that is the derivative of the tan of x, di ba? Minus ito. Ano yung tan of x? Di ba kapag we have the integral of tan u, that is equals to the negative ln of cosine u plus c. So ito ay negative ln cosine of x plus the arbitrary constancy. And that is now our final answer. Okay? So, thank you.